a circular path of radius r. So as before, the speed will be same at each point, but the vector, the velocity at point A and at point B, and that at point B will be not same. It is along the tangent as shown in the figure. Okay. So based on previous concept, we know that the centripetal acceleration is also toward the center. So at point A, it is toward the center. Okay. So positive value will be AC. At point B, the centripetal acceleration is also toward the center, AC. So we know that the centripetal acceleration will be v squared over r. So v is the speed, and here this r is the radius as before. Okay, so it will be same. The positive value will be the same at every point. So according to Newton's second law of motion, mm, second law of motion, we can write, let's say, second law of motion, acceleration is net force over mass. So here, summation F is the net force, is the acceleration, and here M is the mass. Okay, so this equation clearly tells that the direction of acceleration A and the total force or the net force summation F will be same. Okay, based on that, we can say that at point A, centripetal force is also toward the center. So at point B, the centripetal force is also toward the center, Fc. Okay, if you take the other point here, the centripetal acceleration is toward the center, and the centripetal force is also toward the center. So you can use the Newton's second law here. So A equals total force, net force over mass. So here is this is the centripetal acceleration, or we call it radial acceleration, here. So this can be simplified as AC equals net force. I will write just F net. So I'm using same F net symbol is same as summation F. This is just a matter of symbol. Okay, F net over mass. I'll be multiplying both sides by M. This M cancel out. So F net here is called centripetal force. F net equals M times AC. So this F net is centripetal force or radial force. This total force. So instead of F net, we could write FC, which will be equal to m ac, centripetal acceleration. This can be written in various form, just like fc equals m ac. We know that this is v squared over r, because we know ac equals v squared over r. This can be further simplified as m, v is r omega, so it should be squared over r. So I can write fc equals m r squared omega squared over r. That gives me fc equals m r squared cancel out, m r omega squared. This is just a simplification of the main equation, fc equals mac. You can go further and simplify further. fc equals mr, omega is 2 pi f frequency. If you remember, omega is 2 pi times f. Here, omega is the angular velocity, and f here is the frequency. So I can write like this, fc equals 4 pi squared mr frequency squared. So these are the various ways to write the equation for centripetal force. So again, reminding that centripetal force is always toward the center at every time. This is not a new force. This is the total force. Okay. Based on this concept, we can solve one problem here. Say, in first part, we need to calculate the centripetal force. Let's start with that. So, in this case, the mass, radius, and speed is given. So I can use the equation for centripetal force, which equals mass is 750 times 20 squared over 500. That gives me 600 Newton. Okay, that is the centripetal force for the first part of the equation. Now, we have to find the static friction, coefficient of static friction. The situation is like this. Say this car is traveling in a unbanked curve. So that means if this is the we assume this is just circular path. The car is traveling over here, for example, like this. So if you see the force diagram for the car, so this is the force diagram or free body diagram for the car. So earth will be pulling vertically downward, which equals weight. A force exerted by the surface in the perpendicular way, perpendicular direction is n. Instead of that, I will write Fn, and F is the friction force. So let's look at this free body diagram. So I choose my coordinate system just like this. Left, I consider negative x, right positive x, up positive y, and down the negative y. Okay, so these are the forces acting on the car. So Fn, I just write Fn instead of n. Fn, force acting vertically upward, weight acting vertically downward, and friction, in this case, is acting towards the x-axis, but towards the negative x-axis. Okay, so again, the picture looks like this. The car is traveling in a circular path of radius r. We are assuming the road is the level, road is the road is looks like a this plane. plane surface. So we can use Newton's second law here for x-axis. Our net force, our total force will be just equals to friction, but this friction is along towards the negative x. So this minus is just because of coordinate system. So this gives us the net force toward the center. So this is basically centripetal force. So Ft equals minus F. So F we can write equals negative centripetal force we already figure out, which is 600 Newton. 600 Newton. Similarly, we can do for y-axis. For y-axis, we can write the Newton's law as net force along y-axis equals mass times acceleration along y-axis. So this is AY is acceleration along y-axis. In our case, AY is equal to 0 because no motion along y-axis. You can look at here. Okay. So the net force in our case is Fn minus weight. So Fn is positive along being the positive y-axis minus W equals m times 0 is 0. So Fn equals W, which equals mass times value of G. So Fn equals weight mass is 750 times value of G is 9.8, which equals 7350 Newton. Okay. So we have to play with X and Y axis separately. So we know the coefficient of static friction equals friction force over the normal force. So I will substitute those numbers. This will be 600 over 7,350. That gives me 0.082, which is nearly equal to 0.01. Okay. So that's how we use the Newton's second law to solve this problem. You can try similar problem. Follow the same step to find speed. Okay. So again, you can write Fn and follow the same step as we did before. Okay.